Okay, the next topic which I'll cover now is how to add columns to your data frame. Now, before I actually start using the data frame, I would like to execute some statements from here, especially the ones which we imported and we created the data frame. So I'll start from here. Okay, so I'll just run this one. Okay, and let me, I'm using which table df. So if I need to run that as well. Where is the command? Read CSV. Here it is. Okay, so I'll execute this so that my file is ready. Your data frame is ready. Okay. Now let us see how to use conditional you can statements and add a column to your data frame. Now to do that, if you remember, what I'll do is I'll create a new column by the name miles category. Okay, and depending on the miles covered, like if the miles are greater than say 5, I'll make it as a trip, as long trip. Otherwise, I'll make it as short trip. So all the trips which are less than 5 miles will be categorized as short trip, and the others as long trip. Okay. To do that, I'll require a NumPy because I'll be referring to some arrays as well. So first thing, I think we have already imported NumPy. If it gives error, we will see how to do it. So first of all, to add a new column, it's very simple. We have to give df the name of the data frame, and in the square bracket, mention the name of the column which you want to add. So I'll be adding miles underscore CAT category, and I'll put an asterisk because all my columns have an asterisk at the end. Okay. Now this I have to assign some values to it, but now the values are going to come through a where condition. So I'll be using np dot where. Now np is especially we are using the numpy. Let me import it because if suppose by chance I have not imported, it will give me an error. So let me import numpy as np. Okay, and here we go. In the where function, the condition is given here. And this time the condition, as I told you, if the miles field, this field here, if the distance traveled between the two cities from start to stop, if it is more than 5 miles, then I'll treat that as a long trip. So to write that, I can again write df and the column name miles star if this is greater than 5. Okay, if it is greater than 5, then assign long trip, else short trip. Okay. Once I do this, I would like to display the records, but I display only the first 5 records. So I'm using head function. Let us execute this. Here we go. And you can see this last column has been added now as miles underscore cat and an asterisk that is for categories. And depending on the miles, you can see this long trip because this is more than 5 miles. This is exactly 5, so you have short trip and so on. Clear? Now, this was just a simple example where we added one column. If suppose I do not want this column, any one of the columns in my data frame, I can even drop that particular column. To drop, what I'll do is I'll drop the same column again. So to drop a column, I can write df square bracket, uh, or let us write df equal to, because I have to assign it back to the data frame. So df dot drop is my function into round brackets. I'll just mention the name of the columns which I want to drop. So here I have columns equal to, and it will be a list of columns here. Now in my case, I have only a single column. So miles underscore category, which I have just created, and I can just press enter here. I'll print values again. I'll print only the first few records. Let us run this. Here you can see now this was the column which I had added, and now it is been removed. Okay, there's something in the chat. There's some question. Okay, so what if we want to display only miles and mile cap? Then in that case, you can make use of the two functions which I covered last time. That was iLock and lock. Okay, so instead of df dot head, you can give df square bracket or dot iLock and give the index positions of those two columns. Or you can also use the lock function and mention the column names. Okay, that is how you can display it. Now, why I had dropped this one is because I want you all to do something. If you are working, how many of you are with the laptop and working simultaneously? Anyone? Okay, if not, I have one question. What I want is, I want you to create a new column with some conditions. If suppose the miles column, the value in the miles column, if it is greater than 10, then I want you to create a column with the value long trip. Between 5 to 10, I want it to be medium trip, and less than 5, I want a short trip. So here I have multiple conditions. Okay? And the reason why I dropped it, because we had only a simple if where condition I had used. Now, instead of using a where, I'll be using a select, you can say, function. Now, to achieve to use these three different conditions and add a column, what I can do is I can create the three different conditions and store it in a variable as a list. So I'll create let us create a variable or a list called conditions, and inside this square bracket, I'll write the different conditions which I want. So first condition here we have is I want df miles and a star asterisk greater than 10. Okay, this is my first simple condition. The second condition is, again, I have to use the round brackets. As I told you, all your conditions should be enclosed in a round bracket. And especially if you're using the logical and or, the round brackets are compulsory. Okay, so again, between say 5 and 10, so I can give your miles asterisk. Here let us use greater than equal to 5. Okay, and so outside the round bracket, and again in the round bracket give the next condition df miles less than equal to, this time it will be less than equal to 10. Okay, this is my second condition. Put a comma, and the third condition is all the values which are less than 5 will be treated as short. So the last condition here will be, again I'm using a round bracket, miles asterisk, go outside the square bracket, less than 5. Okay, so I have put all the round brackets properly. Yes. So these are my three conditions, which based on which I want to add values to a new column called miles category. Okay. Now, what are the values which I want to add will come in a different variable. Again, a list here. So I'll create a list of strings. Say long trip. That's my for the first condition. Now you have to map it. The first condition was greater than 10. That's why I put long trip first. Second condition is between 5 and 10. That is medium. So I can give you medium trip. And the last one is short trip. Okay. Now using this list, now I can make use of the select function. So we will add the new column first. So the new column will be miles category, okay, equal to. Now again, I'll be using the numpy function select. Okay, inside the round brackets, we have to just pass the two parameters. The first one is your conditions. Okay, conditions and the values. Okay, and now what I'll do is after this, I'll just display some few records. This time I'm passing n equal to 10. So I'll display the first 10 records. I hope it works. Fine. There it is. So here you can see this is medium trip, short trip, long trip has been added properly, and this is my new column altogether. Clear? I hope there is no doubt about it. So remember, if it is a very simple, straightforward if-else statement where there are only two conditions, true or false, the values, and if you want to add a column, then you can make use of the where function. Whereas if you have multiple conditions based on which you want to add the values to the column, then in that case, the best way is to use the select function. Okay, you could have given this whole, all these functions inside here, and then the values also, but then it becomes very complicated. Okay, its best way is to create a list separately, and then pass this list as parameters to the select function. Okay, let us go ahead, and the next thing which we can see is the group function. We there's a question from Advait, could we have used for loop? You can use for loop as well, but when we have some facilities where we can use a simple statement and do the coding, it's suggested that you make use of such things. But if you are not getting, because see, Python is not a very small type of a language. It's very vast, and there are different ways of doing things. Okay? So if you're not getting it through such where conditions, select conditions, and other way, if you remember, even last time I think you had a query, and I suggested you use a for loop. Okay, so the best way is if keeping it very simple. If you are not aware of the different functions which are available, keep it simple. You can make use of the different types of loops or the if conditions and try to do the things which are required. Even that is possible. So there are different ways. In fact, I can tell you there are different ways of doing the same thing. Some are very complicated, the complex way of doing it. Some are very simple, but it requires more statements to be included in the, you can say, in the code. Clear? Next is the next topic which I want to cover will be your group by summarizing your, you can say, data frame or your records. Okay. Now there's a function called group by. So I'll just take a very simple example. I want to group all the cities, you can say, and find out the mean of the miles column, because that's the only column which is having numbers there. So if I want to, for each start location, if I want to find the mean distance which is traveled, how do I do it? First of all, I need to group it by city, and the cities are stored in this variable start. So I can write df dot group by into round brackets. The parameter is the name of the field on which you want to group it. So I'll give it in double quotes, start, star. Okay. Now I won't give the other field which I want to return. I can just give dot agg, okay, into round bracket. This aggregate is a function where we can pass the function which I want to execute on that particular variable. So I'll give mean, okay, like this, and let us see whether it works. Okay, I'll press. Here we go. Now you will say that I have not passed the miles column, and how come I got the mean of the miles? Simply because here I want to group it by city, and I want to find the mean of all the values which are integers here. But because luckily in my data frame I have only a single column with the numbers in it, So it is giving me only the miles column here. Otherwise, if suppose you have multiple columns with numbers. Now, if you remember, we had another table stores which we had imported last time. Is it here somewhere? Where we actually, I hope it is there somewhere. Okay, I cannot see it right now. But if you remember, we had that December, January, February, and so on. And we were trying, I think it is not in this one. Might be I'll come across that table, I'll show you how it looks. This one way of, suppose, let us say there are multiple columns which is having numbers in it, and you do not want to know the mean of those columns. Okay. Now, because luckily, as I said, there was only a single column here. That's why I got only miles. The other way of doing it is what you can do is after giving the start where the variable where I want to group it, I can give the square bracket and I can specify the column whose mean I want to find. So I can give you miles and I can give you asterisk sign. Okay, dot aggregate and the mean. And I can have, let us say I want to display only some few first values. Here we go. Okay. So you can see this one, the last one coming down. Yeah. These are my 5 records. And you can see this is the name of the city on which it is grouped. And this is the mean value which it is returning. Okay. In the previous case, when I did not specify the column, I got the output in a different way. Okay. This time I'm getting only the first 5 records. And this is my, you can say, field on which it is grouped. Clear? So it can happen in some cases, you want to group by, multiple fields. Okay, it is possible, or you want to, you can say, perform multiple operations on the same field. Like for example, on the same field, I want to find the mean, and I also want to find the sum. Okay, so in that case, how do you go about doing it? Simply, what you do is, okay, some question here. Yes, we can group. I'll take an example of how we can group multiple columns as well. Okay, so if suppose initially I want to group it by say the city, and then I want to group it by some other field, I can do it. So multiple, you can say columns are possible, but it is a bit tricky. We'll check how to do that. But the example which I was taking was suppose I want to perform 2 operations on the same field. So how do I do it? I'll write first of all group by. The first one is the variable, start variable. Okay. And now I want to, let's say I want to find the mean and the sum also. So because I have the same field, so I won't give the field here. I'll just give EGG. And in the round brackets, now because I want to perform multiple operations, the name of the, you can say the functions which I want to do, or I want to carry out on the field will come as a list here and not a simple in double quotes. So I need to put it in square brackets. So in the square bracket, the first function which I want is the mean function. And the second one is, let us say, sum function. Okay. And let me display only the first few records. Here we go. So you can see this. This is my sum function, the mean function, and I'm getting the values here. And this is the value for the sum. Okay, one more thing you might have observed. This is not in a very presentable way. You can see this, the column headings have changed now. It says miles, and then we get mean and call sum here. And this is the start. Now, what you can do is if these 2 different columns have been added and you want to store it in a data frame, you can give some names to these columns like we did using the conditional format. You can also give the column names directly and then store it in a different data frame altogether and use it for your requirement, whatever analysis you're doing. Okay. Let us go ahead and I'll ask you a simple question. If you want, you can just try it out on your own. If suppose I want to find out the recent and the, you can say the earliest travel date and the mean distance traveled for each start city, how you will do it? I'll again repeat it. If suppose you want to find out the most recent and the earliest travel date, that means I want to find out the minimum and the maximum, you can say, the date and the mean distance traveled for each start city. How you will do it? Anyone? If you have some inputs, you can give me, or I can directly show you. Now, in this case, again, because I have multiple functions are there, first of all. Okay. And again, in this example, I have to find out for each start city. So I'll be grouping it by the column start. Okay. But if you look at the different functions, I want to perform two different operations on two different fields. Okay. So we can group multiple columns ascending of start date and mean distance. Okay, Advait, you can give a try out of it. I cannot say whether it will work out or not, but definitely you can have multiple columns. Now, in this case, because I have to group it by city, first thing I'll do is I'll group by city. Then there are two different functions which is going to work on two different variables or two different columns, you can say, because I have to find the maximum and the minimum date, the start date, right? So the first column will have on which I want to work is the start city name, that is start. Second is on start date. And the third one is on the miles because I want to find out the mean of the miles as well after grouping it. So in this case, especially when I write it, I'll give a try here. So first thing I'll do is I'll group it and try to display the, you can say, dates first. But before that, I need to check the data type of my data frame. So if I say df.dtypes, okay. Now, if you look at the columns which I have, my first two columns, especially I want to work on the start date. The start date is of object type. So even if I try to find out the minimum value and the maximum value using the min and the max function, it won't work out. Reason because it is not a date. Okay. So first thing I need to do is I need to convert this into a. If you remember, last time we saw how to convert this into a date. So quickly, I'll convert this into a date first. So let us write df. The name of my column is start underscore date and an asterisk. This I want to convert into a date time type, you can see. So we are going to make use of PD here, pandas. Okay, dot. I hope we have imported it, so it will work out to date time. Okay, and if you want, you can also make use of that other format. I think last time I showed you how to give that format. So to date time and to convert, I need to give the variable name again. So start underscore date and okay. If I execute this and there's no error, it will work. Oh, there's an error. Might be the pandas are not imported. So let me import panda first. So I write import pandas as still error. Might be something else. Okay, let me check it out. It says unknown string format totals. Okay. Oh God. Fine, fine. If you look at the tail, let us show the tail. So we have df dot tail. Okay. Now, if you look at this data frame, the last row is having a value called totals. Okay, which is giving me a problem here while converting. Right. So what I'll do is I will delete this row first and create a new data frame. So for that, I can make use of ilog. So I can give df equal to df.ilog. Now from ilog, as you remember, we can give the index positions. I want all the rows except the last one. So I can give you a -1. Okay. So from the beginning till the end, but without the last row and comma and all the columns. Okay, it's very simple. Press enter. Now let me check df.date. Fine. So you can see this now. The last row has been deleted. Fine. Now I'll execute this line where I'm actually converting it to coming back here. Okay, I'll execute this. Fine, it works. There's no error. Okay, and now when I see, I'll go down here. Now when I see df.dtypes, here we go. So it has converted my start date to date time. And now I can easily make use of the min and the max function to get the minimum date and the maximum date. Now let us write the group by function. Now what I'm going to do is I'm going to create a new data frame altogether by the name say result or res equal to df dot group by group by into bracket. What is the first parameter? The name of the field on which I want to group it. So the name of my field is the name of the city is stored in start star. Okay. On this, I want to apply a function. So I use aggregate round brackets. Now here we have to apply two different functions on different fields altogether. So I cannot give, like in the previous example, if you remember, I had given you miles like this. I had given miles here and I had put a star. And then I gave dot aggregate, or you can directly give dot mean as well. But that was possible because I had only one result which I wanted. Okay. Now, because I have two different fields on which I want to perform my calculations, I need to create a dictionary. Okay. The dictionary will have the name of the field and the function which I want to execute on. So the first, the dictionary, as you know, is given in curly brackets. So I'll give the curly brackets. I think I press twice. Yeah, curly bracket. In this comes the first field on which I want to write the function. So miles. On miles, what I want the mean function. So I give a colon that this is my key and the value will be in square bracket. I have to give. Okay. So what I'll do is I'll just run this one and let me remove this. Okay, just run this and check. Yeah, it is working. So I am getting the mean, and let me go ahead and add the second one. I want the minimum and the maximum date, start date as well. So I give a comma after this first key and value. The next one is start date, start underscore date, and then asterisk. Okay, and colon again in the square bracket. I'll pass the function which I want to execute on this. And this time there are two functions. So it will be a list, min and max. Okay. Now when I display res, now let us run this. Here we go. Here we have, you can see this. There's a new, you can see data frame with the start city name. From miles, I've got the mean value. And from the start date, I've got the minimum date and the maximum. Okay, but this data frame does not look good if I have to check the columns of this particular data frame. If I say res dot columns, okay, you can see this. These are my columns now. Now this is nested columns. You can see this one: start date min, start date max. Okay. Now what I'll do is I'll create new columns for this particular data frame. We'll also see how to create a new data frame and reset the indexes also. Okay, so I'll create a new column. To do that, I'll write res dot columns equal to, and in the square bracket, we'll pass a list. The first one is say in the name of the city, but if you look at the columns here, the name of the city is not available here. That means it is treating this column, start column, as my index. Okay. So I cannot directly start with this. So let me remove this. Let me reset the index first. So res dot reset underscore index. If you remember, this was the function, and we had passed a parameter in place. What do you mean by in place here? When I say in place equal to true, that means I have to replace my data frame. It is same like writing res equal to res dot reset index. Okay, it is same like that. So I first of all reset this. Now let me check the columns. Res dot columns. Okay, now you can see this start has been treated as a column. Okay, so we have now 4 columns. So what I can do, I can write res dot columns equal to, and in the square bracket, list of columns I'll pass. So first one was start. I'll give a name start city. Let us give different names. Comma. The second one was average distance covered. So mean. So I can write ABG, DISP, distance. Next one is the minimum, or you can say the earliest date. So earliest date I'll put here. Or the earliest date. And the last one was the latest. Okay, and then I display the value res. Let us display the first few records. So I'll say n equal to 10. So this, I think, this data frame looks better compared to the one which we got before, where we had nested, column names. Okay, here you can see now the index column has changed. I have 0, 1, 2, 3 as my index column. Previously, when I gave that command, your city name was considered as the index, which will give me problem if I have to, refer to or perform any calculations on that particular data set. Okay. So this is a bit complicated at the beginning, but if you practice it out, I think it will be easy for you to understand. So I hope you have understood how to, group it, and then, if you have multiple functions, how to apply the multiple functions on different types of fields and all. We'll take more example as we go ahead, but I think I would like to go ahead and take some more example on some other topic. We have done loops before, and if you want a simple loop, if I have, let us take an example of a loop. I don't want to actually show you loop. I want to show you a compressive loop. So if I have an array like this, and I want to, let's say m equal to 1, 2, 3, 4, and I want to access it. I want to access this array, a 1D array. Okay, actually, logically speaking, it's a list. But if we treat this as an array, I want to access each of them and store the square of each of them in res. So how I'll do it, I'll write for I in m, okay, colon, res dot append is the function which will help me append the values in my res array, and append what? Append I into I, the square. Okay, and then I can come here. Let us not write res here, let us write r. So r. Okay, and I want to display the value of r. Okay, so here you can see it 1 multiplied by 1 gave me 1, then 2 square, 4, 9, 16. Now, this is not the purpose of why I showed you this. If suppose I want to write this in a very comprehensive way, so instead of writing all the statements, I can write in one statement the whole volume, okay, as a list. So because I'm creating a list here, first thing I'll do is I'll put the square brackets. Then I write x multiplied by this is my variable in which I'll be accessing or getting the values. Say for x in 10. That's it. This will work out, this one line. And when I run it, you can get the values. So what I did using, how many lines? 1, 2, 3, 4, 5 lines. I can do it in 1 line. This is how you write your comprehensive, you can say, create a comprehensive list through a for loop here. Okay. I hope I once, because I'll be using such type of notations further. That's why I wanted to show you this. Okay. Let us go ahead, and this time I'll access some different CSV files. So for that, I need to go to my home page. Let me check whether I have this file called store sales. Yes. So yeah, I'll be using this file now. Now this is my file which has store ID, CP, and we have some months out here from Jan to December and the sales figure. Okay, these are my sales figure as per the CP and as per the store ID. So I'll be opening this file. So let us go ahead and open this file first. So to do that, I'll create a data frame called store underscore sales equal to simple pd dot read CSV into round brackets. The name of the file was store underscore, whether underscore was there. Let me check it again. Yes, underscore sales dot CSV. Okay. Once I read it, I would like to check it out because I hope it reads properly. Sales dot head. Okay, so it is reading it, and this is my first 5 records. Now on this, why I have taken this table is because if suppose I want to find or I want to write some functions like we did mean and max, min, and minimum function or count function, whatever functions we were using, we were actually performing it on the column. Now in this case, I can perform it on the column, see on the Jan column also. If I want to find the mean, I can find it out. But what if I want to find it across the rows? Whether I can do it. That is why I have taken this CSV file. Now, let us say you want to find out the average sale for each month. Okay, it is a very simple statement. So what I can do is I can write store underscore sales, and because I want to group it, either I can group it. The only column where I can group it is by cities. Okay, so I'll group it by city, group by into bracket double quotes, cities in small case, okay, and dot. Now let me check whether I can give mean like this. Yes, I can. So instead of using the aggregate function, I have used the mean function directly. Right. So what is happening? There are actually only 3 cities. Okay, and there are multiple. You can see rows or records. To check how many rows we have, we can check it like this. Store underscore sales dot shape. Okay, so I have 100 rows and 14 columns. Okay, so 100 rows, but there are only 3 cities. So I'm getting the mean value, or you can call it as average as well, of the cities. Now, what if I want to find out the average sale for each store? Okay, there are stores like S1, S2, and so on. If I want to do that, how do I do it? So simply this time I'll be using the function called apply function, and instead of the aggregate function. So let us try that first. Now, if I want to find it out for each month first, let's do that first using apply. So store sales dot apply into bracket apply what? I want to apply the mean function. So I can get this way, and when I run it, here you can see I'm getting all the months. So month wise, I am getting the mean value. Okay. So the full Jan, irrespective of the cities and all, it is not grouping it. We are not grouping it here. I just showed you how to apply the mean function. and I'm getting it as per the months here. Now, what if I want to apply as per the, you can say stores. Okay. Now, simply I'll be changing this. So I'll give this function is same. So store underscore sales dot apply inside the bracket me. But now there's one additional, you can say parameter which will be passed. That is access equal to 1. 1 indicates across the rows and 0 indicates across the columns. If you remember, we have done this before as well when we were actually doing NumPy. So now when I run this, here we go. I'm getting it, I think, yeah, fine. So this is across the columns and you can see the values are there. And if I change this to 0, I get the other values. Now compare this value 14.46 and see. So this is across the columns. So Jan, Feb, and everything is coming here. And if I change this to 1, this is row wise. Okay, or you can say as per the store ID. Okay, but we are not able to display the store ID because it is directly applying the function here. Now, what if I want the store ID as well? Okay. Now, for to do that, I'll take some other example. Let us say I want to give bonus to the different stores who are having a good sales number. If suppose they have got sales figure of say, greater than 15, I want to give them bonus. So first of all, I need to check whether they are eligible to get a bonus. Now, if I want to do that, we will write a function first. So as you know, to write a function, we use def definition. Let us name this function as bonus function. Okay. And to this, I'm going to pass a parameter which will be sales number, or let us say sales column, sale call. Okay, this looks better. And in the end, I'll give a colon, press enter. Now here I'll check the condition. Depending on the condition, I'm going to add or return a value. So let us say, let's say eligible values equal to np dot where, and in this we are going to write the condition where the sales call is greater than. Now you can decide the value here. Let us say greater than 10. So if the sales figure is greater than 10, I'll say they are eligible for the bonus, else they are not eligible. Okay? And after this, I have to return this back. So return what? The values which I've collected underscore values. Okay. How do I call this? To call this function, I'll just pass for the Jan column. So I can give you store underscore see, sales into square bracket. I can give I want to create a new column. Let us say Jan bonus by the name Jan bonus. So this is a new column which will be added to my sales store data frame equal to the name of my function is bonus underscore function into round bracket. I need to pass the sales value. Now I'll be passing only the Jan value. I can write store underscore sales square bracket and the name of the column is I think Jan with J capital. Okay. Now if I run this one and now display stores sales. Here you can see now I have a new column which I've got added, which says Jan underscore bonus. And if it is more than 10, you can see this is less than 10, so it is not eligible. More than 10, eligible for bonus. Clear? Now, this is one way of doing it. Now, let us say, what if I want to apply it to all the columns? You know, even Jan, say like December, till December. Now, I won't be, passing all the values or the full you can say the data frame. Even if I pass the full data frame, then there are some fields which are string fields or fields which is not numerical in nature. Now to overcome that, I can use the comprehensive way of writing my code. So either I can apply the function on particular columns by using the function ilog. If you remember, we had used ilog for the index position because the column number one, this is zero, column one. I want to apply this function from this column, that is Jan column. So which is starting at index position 2. Okay, so from 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I don't want to include this one. Now this I have made a mistake by including it or putting it back in the function. But still, let us go ahead and try to write a function which will help me perform the calculation on each of them. Okay, so let me change this now. Now, how do you drop a column? If you remember, we had I told you a function. If I want to drop a column, how do you do it? Anyone? The name of the column or data frame dot drop. So I'll drop this column again. I can write this is store underscore sales equal to store underscore sales dot drop into round bracket the name of the column. So columns equal to in the square bracket. This is Jan underscore bonus. So I don't want this because I don't want multiple columns to get created. So let me check. So I'll run this one here. Fine. So the column has been dropped. And now I can apply this function, that is your bonus function, from Jan to December. Okay. So to do that, I'll make use of the ilog function. I can give store underscore sales dot ilog. Okay. Now, what are the values? I want it to be applied on all the rows. So colon, comma. Now, while applying on the columns, I do not want it to be applied on the 0th column and the first column because we have store ID and city there. That means I have to start from this index position 2 and till the end. So I can give colon and leave it as it is. On this, I want to apply the function. The name of the function is bonus underscore function. Okay. And dot. Let me get the head values. Fine. Here we go. So here we have a new, you can say, data frame, which is applying this function, that is your bonus function. And you can see this for Jan, for Feb, and so on. I'm getting whether they are eligible for the bonus or they are not eligible for the bonus. But you can see this does not make any sense because I do not have the store ID, neither I have the city with it. So what I can do is I can append this or concatenate the two data frames with each other so that I can get the two data frames together. So I can add this data frame to this new one which we have created, or which we can store it in some other, you can say, file. To do that, what I'll do is let me create a new data frame. I can say new store sales equal to. Now to do concatenation, if you remember, there's a function called concat, which is available under pandas of pd.concat. Okay, and there are two data frames which I want to concat. So I'll give it here. But before that, what I'll do is I will assign this new data frame to a different variable. So let us say this is new data frame. Then run this, remove this one. Okay, it's executed. And one more thing I would like to do is I want to check whether there is records in it. Yes, it is doing it properly. Now I can pass the two data frames here in the concat function. The first one is the original one. So I have store underscore sales, okay, comma. Now you can give the new data frame, which will be df. Okay. One more thing, whenever we are concatenate using this function concat, actually it can concatenate row wise and column wise as well. That means all my records will be added at the end. So what will happen? There'll be multiple, you can say, rows. So instead of 100 rows, it will add the new 100 rows and it will become 200. That is that I don't want it to happen. So I don't want to add rows. I want to add columns. Okay. So I want this to be added as a column. So what I'll do is I'll pass a variable called axis. Axis parameter, I'll assign it to 1. Okay. And here I'll display the new store sales. I hope it will. Yeah. So here you can see now what has happened. I have got the sales store ID, the name of the city. Then we have Jan, Feb, March, and so on. And again, from again, the columns have been added with the same name. So if I see the names of these columns, let us see whether if I say I want to access March value. So in the new store underscore sales dot lock square bracket, I'll use say I want Jan, and let us put all the values. See what has happened. This problem with Jan. Well, let us display all the values here so that I can check it out. The cities. See what was the name? New store. S is not capital. S store underscore sales. Now let me give dot loc Jan. Can I give there's some problem with the new store? It is not. Might be one thing I can observe here is when we are giving this the same. You can say the column headings. You can see this column headings. Let us display all the columns. So if I display store underscore sales dot columns. Okay, so there are multiple columns with the same name. You can see this Jan and Jan coming. Okay, if this is the situation, then this is not the way of, you can say, the right way of adding both the data frames because the column names will be same. What I can do now is I can write another function dot columns equal to, and I create new columns, but the number of columns you can see will be very big, starting from store ID to city, Jan, Feb, and so on. Okay. I hope, I think this is very much clear how to write a function, how to make a call to the function, and so on, and how to, you can say, merge two data frames together. But this has become more complicated now, so I will avoid this now. There's one more way of applying the function. The main purpose of this program, which I was showing you, was to show you the functionality of this apply function. Now you can also create and apply the function, create the function inside the apply function itself. Okay. If you remember the keyword lambda, if you, I think when we did functions, we had seen how to create a function without name, you know. And what we had done was we had used lambda, and we can, in this case, we can, what I can do is I can use apply inside the bracket. I can write the full function inside the round bracket itself and perform the execution and check whether the stores are eligible for bonus or not. Okay, even that is possible, which we can do. To just show you how to do it, I can write it like this. I can say store underscore sales. Now, because I want to apply it on only the columns which and not the first two and all the rows, I need to give 2 here, like we did in the previous case. Now directly I give apply, and instead of giving the name of the function which we have written, I can write the function inside this. Now, how do I do this? I write lambda and start with this function. The parameters sales. Let us say this time I call it sale calls. It was okay, or colon, and I can write say eligible if x is, let's say this time greater than say 15. Else, so I'm using your if else, else not eligible. Now, how do I get the value of x using the for loop? So for x in sales number or sales call. Okay, and this will be a part of the square bracket down. And here I can just display, or if I want, I can display this. I think the round brackets over. Right, around this. Here we go. So here we have, I have applied. I've written the function inside the round brackets of the apply function itself. Okay, and this is my 100 rows, 12 columns. It is applied, and I'm getting the outcome. Clear? So even this is possible, but this is more of complicated. You can say the comprehensive way of writing your function. Okay, let us go ahead and I'll just give you one small assignment to try it out. Let us say, please try this out. Find the mean of say quarter sales by stores. So if I want to find quarterly, and then find the month with the largest sales for each store, how you will do it. Okay, so please give a try, just as a type of an assignment. And regarding the database or the data set, the data set is different types of data sets are available on the website. Kaggle, I'm using Kaggle, Kaggle. It's a website where you get lots of, you can say, data sets which are freely available. You can download any one of them. Okay. So please, if you want, you can give a try. And if you want, if you're not getting it, you can, I'll mail it to you all. You can use that as well. Now, let us go ahead and pick up a new topic again altogether. I'll be doing some visualization I want to show. And one more thing, if the time does not permit, I want you all to come back and join the session again. Okay. Now, to do this, I'll be requiring some other files. I'll just close this one. I'll close this file. Can you hear me? Can you hear me, guys?
Yes, sir. Yes, sir.
Okay, thank you. Actually, my headphone got the earphones got discharged. Okay, let us continue. What I'll do is I'll create a new file altogether. So let me create new Python file. Okay, this is my new notebook. Now the first thing I'll do is let me import pandas here. So import pandas as pd, import numpy as np. Now for visualization, as if you remember, we had used matplotlib in previous example. So I'll import that as well. But before that, I'll also going to import a new package. It is your Seaborn package. So I'll write import Seaborn as SNS. Okay, this is everywhere they make use of the same alias. For Seaborn, it is SNS, like for pandas, it is PD, and for NumPy, it is NP. Okay. Uh, After this, I'll also import the matplotlib, and from this, I want to import pyplot, okay, as PLT. Okay, we have already done matplot before. One more thing is I want all my graphs to be displayed here on the screen. So for that, I need to, if you remember, I had set a property to inline property so that it displays the content on my console. So for that, again, I need to set the matplotlib, matplotlib inline. This will display, otherwise it plots the graphs, but it is not displayed on the screen or the console. So using this inline, this statement, don't forget the percent sign, percent matplotlib inline. Okay. Now for this example, I'll be using another file, which is housing CSV, housing, let me check housing price, whether I have imported. If it's not imported, you need to import that. Whether I have housing. Yes, it is. So this one, housing prices.csv. Let me show you the file here. It's a very big file. Okay, and it's very, even the column headings are very complicated. You can download this file again from Kaggle, and you can also download the description of that particular file. The description will give you the information regarding the column headings, because in the column headings they have used very words which you won't be, what it is storing is not known. Okay, so try to download that description file. I'll also show you on the screen here. So let us go back. I'll close this one. Okay, the first thing I'll do is I'll read this file. So I'll create a data frame by the name housing equal to pd dot read underscore csv into round brackets. The name of the file is housing underscore prices dot csv. Okay, and let us see housing. I want to see the shape. Okay, did it read it? And yes, okay, the file is so big. There are 81 columns in it and 1460 rows in it. Okay, so it's a very big, you can say, file with lots of information regarding the house. And it is basically a file from, I think, US. Okay, so US housing prices. So it might be having features or some columns which are not relevant here, but just for our example or for the practice purpose, I'm using this one. If I want to know what are the different records. We'll see the first few records by using the head command. Okay, so you can see this one. It is displaying some values here. Okay, and I can also see the columns. Let us see the columns. Okay, so these many columns are there. Huge list of columns. Okay. Now, I'm not interested in the other columns. Mostly in this particular example, I'll be showing you how to chart some graphs or plot some graphs. There are two different types of, you can say, types of charts which can be drawn. One is for your univariate, in the sense when we talk about a single variable. If I want to plot a single variable on a graph, you might be aware of the histogram. So histogram is used when we have a single variable or a univariate. Okay, so let us plot this a lot area. This one, the lot area. We will plot the lot area using a histogram. And as I said, it is I want to analyze the spread of the lot area column. So I can use CNS. The function which I'll be using to plot a histogram is dist plot. Okay. It the parameter is a simple parameter where we have to pass the name of the column. Here the name of the column is lot area. Okay. And there's one more parameter which it takes, which is KDE equal to false. I'll explain you what a KDE is all about just to show you how it looks. Let me run this one. Here we go. So this is my first, you can say, chart which I've drawn. But if you look at the chart histogram which has been drawn, you will find that my data is more concentrated on this side, less than, you can say, 50,000 lot size. Okay, so majority of my records falls in this bracket of from 0 to 50,000. Okay, there are some, you can say, lines here. If you want, I'll just change this KDE to true, and you will see a curve also along with it. So here you can see this is your KDE. There's a curve here. You can see this one, and there's a line which is going here. Now, what is KDE? KDE stands for kernel density estimation. Okay, it is a way to estimate the probability density function of the continuous random variable. Now, this lot area is a continuous random variable because the values, there's no limit to the value. It's not categorical. Okay, it is a random variable. Now, it is also used for your non-parametric analysis. Okay, if suppose you do not want the histogram and you want only this KDE to be displayed. So what I can do here is I can just write instead of this, I'll make hist equal to false. Okay, and I won't get the histogram, the bar which usually we get. I'll get only this line which is coming here, which is known as your kernel density estimation. Clear? Now this is one way. The other way of drawing a graph using the count plot. Okay, so if I want to know the different types of house exteriors, now there's a field out here which is say exterior first or something like that, which I had seen here somewhere. Exterior, you can see this exterior first. Okay, so if I want to know the different types of housing exteriors, I can plot a graph. This time it will be a bar graph. So I can write plot equal to SNS. No, I won't write plot. I'll write SNS first. SNS dot count plot into bracket. For the x-axis, I want the field as exterior first. That was my field. and comma, the data is coming from housing. Okay, and now when I run this, I get a bar graph. Here you can see. Now the problem with this graph is that the name of the exterior is overlapping. So let us do something. I'll change this to say plot equal to, okay, and I'll rotate the label. Now the labels can be rotated because they are known as your tick labels. So if I want to access that, I can write plot dot set underscore x tick labels into round bracket plot. Now plot is the variable where I have stored this graph. Okay, so plot dot get x tick labels. So I'm getting the labels first and then I'll rotate it and assign it back. So rotation equal to, you can specify any degree you want, say 40 degrees is okay. Okay, you can see this now. So these are my labels, fine. These are my labels here. And once we set it, you can see it has been tilted now at 40 degrees. Fine. The bar graph, the color is taken automatically. And if you remember, I told you there is only two things which I'm plotting here. The first one, I plot the lot area using the function dist plot for histogram. Okay. Now histogram, I cannot put this as false. EDE equal to false. This is how it looks. Fine. This basically these two graphs are for univariate analysis. If I have more than one variable which I want to plot it, in that case, now if even in this case, it is just giving me the count. This is the count. And that's the reason the function which we have used is count plot. Okay, the count plot. Okay, so for each you can say exterior, it is counting. This is I think something vinyl SD something. Okay, so maximum of the exteriors are using vinyl SD. Fine. Now, what if I want to use more than one variable? That is bivariate analysis. If I want to do bivariate analysis, in which if suppose I want to find out the price of a house, whether it depends on the lot area, like we have already seen the lot area. So for such type of a question or such type of analysis, if I want to plot a graph, I'll be using a function called rig plot. Okay, so I'll get a scattered plot. In a way, you can say scattered plot in Excel. If those who are aware of Excel and those who have done lots of graphs, if you remember, there's a graph called scattered graph. Okay, your rig plot is nothing but a scattered plot. To do that, if suppose I want to find the price, the relationship between the price and the lot area, I can do it like this. I can give SNS dot rig plot. Okay, that's the function which we use. On the x-axis, let me say I want to put the lot area. And on the y-axis, I want to give the price. So what is the name of the field? Sale price, something will be there, sale price, this one. So I'll be using sale price there. So on the y-axis, so I give y equal to sale price. Okay, and I have to pick up the data from data equal to housing. Let's run it. Very simple. Immediately I get a scattered plot with a line in it. And plus you can see this is my lot area on the x-axis and the sale price. and there's a line which is going upwards, that means there is some relationship between the lot area and the sale price. But as you can see, it is not at a 45-degree or more than that. It's not a very steep line. So the relationship is, you can say, very less. Okay, there's hardly any correlation, you can say. But one more thing you might be noticing, there are some, points which are plotted, way far ahead, and the sale price is less, whereas the lot area is more. So, for example, this point here, or these 2 points here, even this one. Similarly, the lot area is less and the price is high. So there are some points and some grouping has been done here. There is some cluster out here. Okay, so this indicates that there is a slight relationship, but not very much. So to check the correlated values, let me use a function called correlation, or let us check the quantile of this particular data frame. So I'll use housing square bracket. Let us put the lot area. Okay, and let us see the correlation first. Let us see the quantile. That means I want to know uh, the description. Let us put the description. Or let us see the quantiles first. Let us see the quantiles first, which will tell me how it is distributed. Lot area, especially on lot area. If I can use the function describe. If you remember, we had used describe function, which will give me all the information of all the fields, but I don't want all the fields because there are 81 columns. So it will become difficult for me to check it out. So we'll specify the name of the column on which I want to see the quantiles. So QUNTIL, quantile, and I want to check the values of say 50%. So it will be 0.5 and 0.95, 95%, and 99%. Okay. Now, what does this value indicate now? Now, if we observe these values, you can see the first one where we have 50%. So 50% of my data has values between, I can say, the maximum value up to 9,478.50. Okay, so this is my 50%. Whereas if you look at the value of 95%, it is literally doubled. Okay, whereas 99%, the lot area is coming to 37,567. That is too huge. That means this indicates that I have lots of, you can say, outliers. So these points, which is going beyond, they are not in this cluster here, indicates that I have some outliers, which is actually changing my overall correlation. Let us check the correlation first. What is the value? So I can give housing lot area dot CORR. Now this is the function which I can use to check the correlation between this first variable, and I have to check it between the sale price. So housing sale price. Run this. Okay. Now, as you see, the correlationship gives me a value of 0.2638, which is very less. Okay. Why it is so? Because what is happening is, because of this higher values, which are outliers for this particular data set, it is giving me a different picture altogether. So I need to, filter out this values and remove this outliers from my data set so that I can create a proper correlation. So to do that, what I'll do is I'll remove all the values. I think let us go. I'll keep only values up to 95% of quantile. Now, what is a quantile? Quantile is actually when, if you remember probability, when we have that curve, we had put the mean in the center. So it was divided into two quantiles. The first part was 50%, the other one was 50%. Now, in case of your distribution here, uh, the first half will be quantile one. Now, if I directly display the describe function, let me show you that. Dot describe. Okay, here we go. Now, if you look at this 25%, 50%, 75%, this is my quantile 1, quantile 2, and quantile 3. Whereas this is my minimum value and the maximum value. Now, we were talking about the lot area. Now, you can compare this lot area, the values. Where is the previous outcome? Here it is. So you can see this quantile 50% is 9478. Similarly, for lot area, this is 9478. Okay, for 25% of my data has the maximum values between, say, whatever minimum value. What is the minimum value? 1300. From 1300 to 7553 is where my observation, first 25% of observations are lying. And 50% of my observations is between 1300 to 9478. Now, if you compare this 50% with the rest of the 50%, which is from 9478 to the maximum value, that is 22 lakhs 15,245, it is very weird, the maximum value. That means there is, you can say, screwness. If you have right screwed, you can say skewed. So if my distribution is right skewed, that means my maximum the observations are shifted towards the right side. Okay, that is what it means. For example, if suppose there are some say 20 people in my class right now, and I want to find out the age of all the 20 students, because you belong to the same age group. Now my mean will come the same, but if suppose I include some person who is of say a senior citizen, let us say age of say 60 or 65 in the group, and then try to calculate the mean, what is going to happen is my mean is going to change. Okay, and as per the mean, it will reflect as if I have all you can say the group which is having that particular person in the group, the mean is will be higher. Okay, similarly, if I want to find out, say, let us take an example of salary. If suppose uh, all the salary of so it's a few people here, plus if I include Mukesh Ambani in that group and then try to calculate the mean, what will happen? Everyone will become a millionaire, because of one person. What is happening? The overall mean is changing. The same thing is happening here because of one value, which is it's not a part of the other group. It is you can say it's an outlier. Because of that, what is happening? My overall chart is looking very different, and I cannot set any correlationship between the lot size or lot area and the sale price. So I need to remove such outliers from my data set. So even in your case, whenever you do some research and you'll come across some values which is not, which is totally different. Either it will be very less or it will be very big. So such values has to be removed from your data set when you're doing your analysis. To remove this values, I'll be using the condition. If you remember, we had used the where condition, and I can also make use of LOC and try to remove. Let us use, say, the quantile. So up to 95%, I think it's fine with me. I cannot go up above that. So I'll create a new data set. Let us say I'll create a new data set called housing sub. Housing sub equal to housing.loc. Now I'm using LOC to refer to the column lot area. So here I have housing in the square bracket, lot area. Now I want all the values which are less than your 95 percentile or quantile. Okay, so I'll give a less than sign, less than housing again, because I have to compare with the lot area itself. Lot area. Here I give dot quantile. Quantile, and the value is 0.95. Okay, and complete the square bracket. Press enter. Now if I see housing underscore sub dot describe. Okay, here we see now I have removed that. Here we go. You can see this now, the maximum has changed. Okay, even your mean has changed. Okay, so mean is coming to 9225 and my 50% is 9247. That means it is near about in the center. Okay, now when I plot the graph, let us plot the graph again. So I'll just copy this function which I had written here. So let me copy this. Paste it here, and instead of housing now, I'll be using the other data set, housing sum, and now plot the graph. Okay, now you can see it is a better, you can say, presentation. It's a scattered graph, and there's a line there, which is again going upwards. And now if I want to see the correlationship, I think it should improve. So where's the function where I used CORR? No, please remember previously it was 0.26. It should be at least more than 0.4 to have a correlationship. So lot area, and instead of housing now, I'll be using housing sum and sub. Now when I run this, okay, what's happening? Okay, S is small. Okay, now I get a value of 0.43, which is better compared to 0.2, right? So that means if I want to say there is a relationship between, a correlationship between sale price and the lot area, that means along with, if the lot area increases, the sale price also increases. That is what it indicates. But the correlationship is not that good because it's below 0.5. Basically, it is said that the relationship is very strong if the value is coming to more than 0.7, and any value above, you can say, between, you can say, 0.4 to 0.7 is average, you can say, and below 0.4 we have less correlation. Or in that case, what is going to happen if there is no correlation? This line which is coming will be a flat line. Okay, or it might be going down as well, can't say. Fine. So I think we will stop here today. It's around 1:20. So we'll stop here. I want you all to just go through this charts and all, and try to understand. Those who are good in statistics will understand it much better. So please practice it. Those who want to learn statistics can refer to some books and some topics on statistics, and then come ahead and write some code in Python. Okay, I'll be stopping now.